Cogover is a unified enterprise management platform built on a no-code and AI-native architecture.
On a single data system, businesses can simultaneously operate CRM, task management, workflows, HR, logistics, and finance.
All seamlessly connected without the need for fragmented integration.
Notably, Cogover enables flexible customization of data structures, interfaces, workflows,
And user permissions, all through simple configuration with no coding required.
In today's video, we'll walk through how Cogover works using a very familiar use case: internal work and task management.
This example shows how Cogover lets you build a complete app from scratch through simple configuration.
Before diving into the demo, I'll briefly introduce the architecture of the Cogover Platform so you can understand how the system is built and why it allows for such flexible customization. Cogover is built on a 3-layer architecture, with each layer built upon the one below. The first layer is the object manager, or the data layer. This is the core foundation. On Cogover, everything starts with object, data entities representing different types of information, such as projects, tasks, employees, and customers. Each object not only stores data, but also includes a drag-and-drop interface, display rules, security policies, state transition rules, and change history. By combining multiple objects, businesses can build a complete application. The second layer is business logic. This layer provides tools to configure BPMN workflows, role-based access control, automation, notifications, document templates, and task assignment rules. It ensures that the system not only stores data, but also governs how it operates in real scenarios. The third layer is the application layer. Based on the data and logic configured in the lower layers, users can build fully functional applications such as CRM, task management, inventory management, HR systems, and extended modules like omnichannel, call center, and order management, all fully customizable to fit the way each business operates. The video will cover the following key sections. 1. Creating the project object and configuring its fields and interface. 2. Creating the task object and setting up its fields and interface. 3. Defining activities to capture communications and updates during execution. 4. Adding the task object to the project. 5. Creating sample records. 6. Setting up data security rules. 7. Configuring state transition rules. 8. Defining interface rules. 9. Creating actions. 10. Enabling field change history tracking. 11. Creating filters. 12. Building real-time reports and dashboards. 13. Creating the application. 14. Setting up automation workflows through Cogover Process. First of all, a well-structured task management application is not simply a list of tasks. The system needs to reflect the actual operational structure of the business. Therefore, you will need an entity representing projects. At the execution level, each project consists of multiple tasks, specific pieces of work assigned to individuals or teams. In addition, to ensure transparency and effective collaboration, each task should include a centralized communication space. This is where activities come in, allowing all discussions, feedback, and updates related to a task to be recorded in one place, rather than being scattered across emails or separate chat platforms. In addition, Cogover provides built-in reporting and dashboard capabilities, enabling real-time visibility into performance metrics, workload distribution, and operational efficiency. Notably, Cogover is integrated with AI capabilities that enhance information retrieval, support data-driven analysis, automate repetitive workflows, and recommend next best actions, thereby optimizing productivity at both the individual and organizational levels. To build a comprehensive task management application, the first step is to define the system's core data objects. I will begin by creating a project object to manage the project portfolio. The next step is to configure the detailed data fields for this object. First, a description field is created with a long text data type, allowing for comprehensive project descriptions. Next, additional fields are defined, such as project status, using a single select data type. A project owner field is also established, configured as a lookup relationship to the personnel object. These are the complete set of data fields defined for the project object. With the data structure now established, I will proceed to configure the user interface for this object. On Cogover, interface design is handled through an intuitive drag-and-drop approach, allowing users to arrange data fields, add related lists, and define display structures without any coding. This enables businesses to quickly build interfaces tailored to their operational needs, while maintaining the flexibility to modify them at any time during execution. Once the interface configuration is completed, the project object setup is finalized and ready for use. Next, I will move on to configuring the task object. First, I will create the object, then define the necessary data fields such as task title, status, priority, assignee, due date, related project, ensuring that each task contains sufficient information for tracking and execution. After creating all required fields, I will proceed to design the interface. By navigating to the interface list, selecting Create, and using drag and drop functionality to arrange the fields, the interface can be completed efficiently. Next, I will add the activity component to the task. This section is used to capture and log all interactions throughout the task lifecycle. To incorporate activity into the task, I first need to establish a relationship between these two objects. I will start with the activity object and create a lookup field that links to the task object, allowing each activity record to be associated with a specific task. Once the lookup field is created, I will return to the task interface design and add the related activity list to the layout. Upon completion, each task will display all associated activities within a single screen, ensuring that all communications and updates are centrally stored within the system, rather than being scattered across chat or email platforms. Within each project, you can see a list of tasks structured in this manner. To establish this relationship between task and project, the task object needs to be added to the project interface. When creating the data fields for the task object, I added a project reference lookup field. This means that the task and project objects are already linked to each other. At this point, I only need to return to the project object and drag the related task list into the project interface. Once this is done, all tasks connected to a specific project will be displayed within that project. In addition to setting up detailed interfaces for both project and task to support comprehensive tracking and management, I have also created a simplified interface designed for quick data entry. This streamlined interface displays only the most essential fields, enabling users to create or update tasks rapidly without navigating through the full interface. Finally, I will create sample records to help visualize the outcome after configuring the project and task objects. First, I will create a sample project. After saving, you can see that the task list is displayed directly within the project interface. From here, you can either create new tasks directly within the project's task list, or create tasks separately from the task menu and then link them back to the project. This approach provides flexibility in user operations while ensuring that all data remains centralized and consistently linked within a single system. After completing the data configuration for the task and project object, the next important step is to establish data security rules to control access and data modification permissions. First, I will create a rule for record creation permissions, configuring the authorized users as all employees, thereby allowing all users to have permission to create new task records. However, for edit and delete permissions, I will apply certain restrictions. Only users directly involved in the task, such as the creator, assignee, assignor, or managerial roles, for example, department head, project manager, will be granted permission to modify or delete task records. This configuration ensures data integrity and prevents unauthorized or arbitrary changes, while still maintaining the necessary flexibility for effective collaboration among team members. As a result, each organization can build an access control model that aligns with its organizational structure without requiring any coding, while still ensuring data security and governance throughout operations. Next, I will configure the task status transition rules. For example, when a task is in the new status, the system will only allow it to transition to in progress and not directly to canceled or completed. This ensures that the workflow follows a proper sequence and prevents invalid or illogical status updates. Once a task is in the in progress status, you can allow transitions to multiple other statuses such as completed, on hold, or canceled, depending on your organization's operational requirements. These transition rules can be fully configured with flexibility in Cogover. For configuration, I will drag and drop the task statuses onto the canvas. Then, to define the transition flow, simply draw arrows from one status to another. For example, from new to drag to in progress, from in progress to drag to completed, on hold, or canceled. With this setup, the system will only allow users to change statuses according to the predefined flows, ensuring tighter process control while still maintaining flexibility tailored to each organization. In addition, you can configure permission controls for status transitions. For example, only the assigned user may be allowed to move the task to the next stage. This helps prevent unauthorized users from changing task statuses and ensures clear ownership and accountability throughout the workflow. In addition, Cogover enables the configuration of UI rules for field visibility and data input. For example, when a task is transitioned to the on hold or canceled status, the system will require users to input a reason before the record can be saved. To configure this rule, I will navigate to the task object and create a new field named hold/cancel reason. Then, I will drag and drop this field onto the interface, so it is available when users need to enter the information. Next, I will go to the UI rules section to define the display conditions. The objective is to ensure that when a task is moved to on hold or canceled, users are required to provide a reason before saving. This rule will be applied specifically to the task management interface to ensure it aligns with the correct usage context. In the condition setup, I will select the status field, set the condition to is one of, and choose the values on hold and canceled. This ensures that the requirement is triggered only for these two statuses, while remaining optional for all other statuses. Next, I will enable the option for automatic action reversal. This ensures that when the status is no longer on hold or canceled, the system will automatically remove the mandatory requirement and hide the reason field, preventing any unintended impact on other operations. Finally, I will define the rule action by setting the hold/cancel reason field to be both visible and required. This configuration ensures data completeness and transparency, while enabling managers to easily review and understand the reasons behind task interruptions or cancellations. Additionally, users can fully configure other rules based on their specific business requirements. Cogover allows the creation of actions, which function as quick action buttons on the interface to help users handle tasks more efficiently. For example, with the cancel action, when a user clicks the button, the system can display a pop-up window requiring the user to enter a cancellation or hold reason before confirming the action. These action buttons streamline user operations while ensuring that all processes are executed in accordance with the workflows and rules defined by the organization. To help you better visualize this, I will create a sample complete action button. First, I will navigate to the Object section, select the Task object, then go to Actions and Action Flows, and click Create New. Here, I will name the action Complete and select the action type as Update Record. I will enable the Run in Background option so that when the user clicks the button, the system processes the action instantly without opening an edit form. Next, I will select the field to be updated, which is Status, and set its value to Completed. After creating the action, I will go to the Interface section, select Page Settings, navigate to Page Content, then click Add Button and choose the Complete button that was just created. With this setup, when users click the Complete button, the system will instantly update the task status to Completed, enabling faster operations while ensuring data consistency in accordance with the defined workflow. Cogover also enables tracking of field change history. To configure this feature, I will first navigate to the Field Change History section, enable tracking, and select the fields to be monitored, such as status and deadline. After enabling tracking, the next step is to return to the interface design and add the Change History component to the task screen. Once configured, every time a task is updated, the system will automatically log the changes and display them directly on the interface. This allows users to transparently track the entire lifecycle and processing history of each task. Cogover allows the creation of filters. For example, you can create filters by task status to quickly view tasks that are in progress, completed, or on hold. In addition, the system supports multiple display formats, such as Kanban view for tracking progress by status columns, or split view to simultaneously view both the task list and detailed information on a single screen. To help you better understand, I will create a sample filter for newly created tasks. First, to keep the data display concise, I will use a simplified interface that only shows key information fields. This interface has already been pre-configured. Next, I will navigate back to the Task object, select Filter Management, then choose Create Object Filter and select the Task object. I will then define the filter condition by selecting the status field, setting the condition to equals, and choosing the value New. After that, I will select the Split View display type and choose the simplified interface created earlier as the display layout. Once saved, users can quickly access this filter to instantly view newly created tasks, making it easier to track and manage work efficiently. Cogover enables the creation of reports and dashboards to monitor work progress in a visual and real-time manner. To begin, I will first create a report type. At this step, I will select the Task object as the primary data source, since all task-related information is stored within this object. Then, I will choose the relevant data fields for the report, such as title, due date, assignee, and others. After creating the report type, I will proceed to create a report. I will select Create New Report, choose the report type just created, and then define the fields to be displayed in the report. Then, I will save the report. I will also create additional reports for completed tasks and on-hold tasks using similar steps. For these reports, I will add an extra step by defining filtering logic. For example, in the completed tasks report, I will apply a filter on the status field to include only tasks with the status completed. This allows the report to automatically compile a list of completed tasks, making it easier for managers to track performance outcomes. After creating these reports, I will add them to a dashboard. In Cogover, building interactive dashboards can be done quickly using drag and drop functionality. I will create a sample chart to display the total number of tasks. For the data source, I will select the report created earlier. Next, in the metrics configuration, I will choose the ID field. Since each task has a unique ID, counting by ID allows the system to calculate the total number of tasks accurately. Similarly, I can create additional charts such as number of tasks by status, number of tasks by assignee, number of on-hold tasks. All of these can be consolidated into a single dashboard, providing a comprehensive overview of overall work performance and progress. The next step is to create an application. In Cogover, I will navigate to the Tools section and then create a new application. Once the application is created, the next step is to set up the application menu. I will create a new menu and sequentially add items such as projects, tasks, and dashboards. After completing this step, the task management application is ready for use. Users can now interact directly within the newly created application, instead of accessing each object individually through the configuration module. Finally, to optimize workflows, Cogover enables the configuration of automation processes. As an example, I will create a process where, when a task's status is changed to completed, the system will automatically send a notification to the assigner to confirm that the task has been completed. The process begins with a start node. From there, I will drag and drop a send notification action and configure the conditions. For example, I will set the recipient as the assigner of the task and define the trigger condition such that when the status field is updated to completed, the process will be executed. The notification content can be customized flexibly, for instance, informing that the task has been completed along with relevant task details. After configuring the notification action, I will connect it to the end process node to complete the workflow. I will then run a test to better demonstrate how the process works. In addition, you can also create time-based processes. For example, at 8 a.m. each day, the system can automatically scan for tasks with due dates on that day and send reminder emails to the assigned users. Such processes help reduce the risk of missed tasks, minimize manual operations, and ensure that work is consistently tracked according to schedule. With Cogover, organizations can create multiple automation processes tailored to their specific needs.
As you can see, With its 3-layer architecture and powerful customization capability,
Cogover enables you to build a complete management application using configuration and drag and drop operation.
Using the same approach, you can build a wide range of applications, such as CRM systems, sales management, customer management, HR management, or other internal enterprise systems tailored to your organization's needs. For example, in a sales management scenario, the system can be structured in a similar way. You can create a lead object to manage potential customers, then link it with other objects such as opportunities, quotations, products, and contracts to form a complete sales pipeline. Each stage in the process is represented as an object, and these objects can be interconnected to ensure data consistency and enable end-to-end tracking, from lead generation all the way to contract closure.
We hope this gives you a clear understanding of what Cogover can achieve for your business. Sign up for a free trial today and experience the difference.